Hello all, let's start the first lecture of your pre-calculus. As I mentioned in my video, in my syllabus, I'll start your book from chapter 2. Today we will cover section 2.1. Chapter 2 is about equations, few types of equations that I will introduce here for you, and also inequalities. But let's start with the first topic, which is quadratic equations, correct? Before even solving quadratic equation, let's talk a little bit about the definition of quadratic equations. What is a quadratic equations? Many of us, we know how to solve a quadratic equation, but we don't know what is that. Which form is a quadratic equation? Let's start with the definition. I will put some notes here, and as I mentioned before, please try to take good notes and also read your book. A quadratic equation is an equation that can be written in the form of this form is important. Which form? In the form of ax squared plus bx plus c equal 0. Here, in this general form that I put for you, ax squared plus bx plus c equals 0, a, b, and c are real numbers. Correct? And a cannot be 0. Let's explain this part. This part is really important. A, B, and C are real numbers, and A cannot be 0. Let's explain why A cannot be 0. B can be 0, C can be 0, but A cannot be 0. First, let's put a numeric example for this general form. When I'm writing 2x squared plus 5x minus 7 equals 0, you see that A is equal to, B is equal 5, which is this number, the coefficient of x, and C is equal negative 7, which is your constant term. Correct? The coefficient of x squared is A, the coefficient of x is B, and your constant term is C. Correct? Or in this example, x squared minus 7x plus 20 equals 0. Correct? In this equation, A is equal 1. Remember, please, this is the last time that we explain in this class. Even in upper classes, we see students are doing mistakes. When they don't see a number here before x squared, when you ask how much is A, they will say, oh, A is equal x squared or A is equal x. No, the coefficient of x squared. When you don't see a number, it means the coefficient is 1. My B is equal negative 7. Sign is really important. Do not miss. Oh, B is 7. B is not 7. B is negative 7. And your C is equal 20. Or another equation. Let's say, like, for example, negative x squared plus 5x plus 2 equals 0. Here, A is equal negative 1, your B is equal 5, and your C is equal 2. All these examples that I put for you, you see you have three terms. But a quadratic equation can have also two terms. What are those cases? For example, when I'm writing x squared plus 5x equals 0. Here you see your a is equal 1, your b is equal 5, and actually your c is equal 0. You don't have a c. If you want to write it in a complete way, this equation is like this: x squared plus 5x plus 0 equals 0. Of course, we don't put plus 0. That's why c is equal 0. Or in this example, when I'm writing, for example, x squared minus 9 equals 0. Here, my a is equal 1, b is equal 0. Remember, b is the coefficient of x, correct? And c is equal negative 9. You may ask, is this a quadratic equation when you write, for example, 5x plus 2 equals 0? Here, a is equal 0. Can I do that? No. Why? What is the reason? That's why I told you in the definition, in the general form, that a cannot be 0. Look at here, I put here, a cannot be 0. Why a cannot be 0? Here, a cannot be 0. The reason is, if my a is 0, it means it's not quadratic anymore. The meaning of quadratic means second degree. It means you should have in your equation with power of 2. If you don't have power of 2, then it becomes linear, power of 1. Correct? You should exactly have x squared to can call it quadratic, or y square, whatever, or t square, whatever your variable is. But the degree should be 2. Then you can call it quadratic. That's the reason that we say a cannot be 0, because look, if I'm writing 0x squared plus 2x minus 7 equals 0, this is not actually a quadratic equation, because you know 0 times any number gives you 0. Then this part goes away. When this part goes away, it's not second degree anymore. We don't call it second degree. We call it, it has a special name, quadratic. That's why the reason that every time in every book that you see when we are talking about quadratic functions, quadratic equations, correct? They put in the definition a cannot be 0. It means the coefficient of x squared cannot be 0. Correct? Now, we learn what is the definition of a quadratic equation. Now it's time to learn how to solve a quadratic equation. I'm sure those of you that you had algebra 2 or algebra 1 in high school, or if you had math 105 or 96 with MSGC, you already know how to solve a quadratic equation. In this book, our more focus in this chapter or in this section, our focus is on two ways to solve the quadratic equation: completing a square and using formula. But in this lecture, I will cover also for you the factoring, correct? Ways, or I can say, let's say, or methods to solve quadratic equations. That's my first lecture. Let me explain something to you. My handwriting with electric pen that I'm using here on Wacom is really bad. But I'm telling you, I'm not that bad in writing. If I use a whiteboard, my handwriting is much, much better. But here I'm using a small Wacom and an electric pen That's why my pen is moving. I have kind of less control on my pen. Maybe my handwriting is not maybe, actually it's really bad. And also if you see misspelling, it's okay, fix it. Okay, sometimes I put like few words. I'm teaching math, not English. Okay, ways or methods to solve a quadratic equation. The first method, number one, is factoring. Some quadratic equations, you can solve some quadratic equations by factoring. Not all of them, some of them. You can solve a quadratic equation by factoring. And we are lucky if we get a quadratic equation that can be factored. Correct? Because this is so fast. This way is really the easy way to factor a quadratic equation and solve. I'll put an example here first and explain how to factor and how to solve it. And maybe I'll explain here one of the most important properties of the equations. Later I'll explain why it's the most property of the equations. I'll explain to you. Also, it's in chapter 1. I already asked you to read chapter 1. If you don't know that property, you will do a lot of mistakes. Later, I'll give you a story of last semester, what happened in one of my classes. Okay, factoring. For example, I have x squared minus 9 equals 0, and they're asking me to solve this equation. Solving an equation, a quadratic equation, it means find the roots of this equation or find the solutions or maybe solution of this equation. In some books in college algebra, your professor was using this word, find the zeros of the equation. Zeros, roots, solution, it's all the same. In your book here, we use the word roots, correct? We use the word roots. Find the roots of the equation, correct? All of us, or most of us at least, we are familiar how to factor the left side of this equation. The left side of the equation is a binomial. You have two terms, and you see it's the difference of the squares. Later, I'll in this lecture, it will be a longer lecture. I also do a short lecture on some types of the factoring to help you out for the last time. If you are not good in factoring, I'll explain to you how to factor and how to know which type of factoring is this. If you have two terms, x squared, it means a and c, and your b is equal 0. If you are a and c, they are perfect squares. Perfect square means the numbers should have a square root. For example, the square root of 9 is 3. The square root of x squared is x, right? They have perfect, we call it perfect square. If you have these two and the sign in between is always negative, not positive, we call it difference of the squares. And how to factor? You open two parentheses as a product. Take the square root of the first term and write down in both parentheses. And take the square root of the second term, which is 3, write down in both parentheses. How to choose the sign? One of the parentheses will become positive, one of them becomes what? Negative. Correct? Now equal to 0. From here on, how to solve this? I told you that I will talk about the most important property of the equations. There is a property for the equations. And what is that property? We call it the zero property of the equations. What is the zero property of the equations? Zero property of equations. What is that? Look, if you have two numbers, for example, A and B, and you multiply these two numbers with each other, and you end up to get a zero when you multiply two numbers and your product becomes zero, it means definitely one of these numbers, A or B, is zero. It means, if I write this way, it means A is equal zero, or maybe B is equal zero. We don't know which one, correct? Why? Because I already explained to you that 0 times any number gives you 0. For example, 0 times 2 gives you 0. Okay? One of them will be 0. We call this the zero property of the equations. Correct? And we use this property to solve such equation here on the left side of my screen. X plus 3 times x minus 3 equals 0. I'm using this property to solve this. But remember, please, that the right side, the product should be 0. If I have A times B equal 4, I cannot say A is equal 4 or B is equal 4. You cannot use this property if you have a number on the right side. It happened. This mistake happened on a test day in a calculus class. Can you believe this? Don't do this mistake, please. That's why we call it zero property. If you have a number on the other side, you cannot apply this property, correct? It should be always 0. Anyway, let's use it. Now, look, I'll use again color notation. The first parenthesis for me is A. The second parenthesis for me, I'll see it as a B. Look, A times B equals 0. Now, from here, I can say x plus 3 equals 0. It means A equals 0. And or x minus 3 equals 0. Now, look, everyone knows how to solve this easy equation, a linear equation. Subtract 3 from both sides. These two cancels out. X equal negative 3. Here, add 3 to both sides. And x equal 3. The two roots of the equation. Correct? The easiest way to solve a quadratic equation is factoring. But if you can factor, if not, there are other ways, formula, like completing a square, that you can solve a quadratic equation. Now, before jumping to more examples or another method, let me help you out with some factoring methods for the last time, correct? Because after this class, no one will explain to you how to factor a polynomial. There are 5 types of factoring. I'm not going to cover all of them for you. The most important ones that there belong to, actually you are using those mainly to solve a quadratic equation. I'll cover those, or maybe 2 or 3 types that I want to explain to you. Number 1, we call it GCF factoring, greatest common factor. For example, if someone gives me like 2x squared plus 4x, I will not put here equal sign. I'm not going to solve this as an equation. You don't see there is no equal sign. it's just a polynomial or a binomial. I'll show you to you why we call it GCF. Greatest common factor. The name is explaining everything to you. How to factor such a polynomial? In general, we call it polynomial. What you do between the terms. For example, here I have two terms. Find the greatest common factor between the coefficients and also between the variables. The greatest common factor between 2 and 4 is 2. Greatest common factor means the highest or the biggest number that the given numbers can be divided by. Remember this. You're looking for the biggest number that the given numbers can be divided by. Correct? Between 2 and 4, of course, the highest number is 2 because 2 can be divided by 2 and also 4 can be divided by 2. That's why you take 2 as a common. We call it factor out 2 or take 2 as a common. How to deal with variables? Always look for the lowest exponent. Take that one as a common. Between x squared and x, the lowest is x because the power of x is 1, correct? Now, open a parenthesis. Basically, you do this in your brain. We don't show every time this, but basically you do this. Most of the students, they know, how do you know what to write inside? Do this. Whatever is common, whatever you factor out, divide these terms by that number and write your answer inside. 2 divided by 2 gives you 1. X squared divided by x gives you x. Then positive, look, even I'm dividing the sign. Positive divided by positive gives you positive. 4 divided by 2 gives you 2. And x cancels out with x. It means you factor them out, right? 2x times x plus 2 is the factor of this given polynomial. The second type, I'm not doing a lot of example because I shouldn't cover this topic here in this lecture, but I'm just trying to help you. The second type is difference of the squares, x squared minus a squared. I already explained how to deal if you have the difference of the squares. Take the square root of the first term, take the square root of the second term, then open two parentheses. If they have perfect square, open two parentheses. And the first parenthesis and second parenthesis, use the square root, correct? Put your result here. The square root of x squared is x. Write it down in the first and second parentheses. And the square root of a squared is a. I know that, right? Write it down in both parentheses. Choose one of your parentheses positive and one of them negative. You are done. Numeric example, x squared minus 36 equals 0. Immediately, this is the easiest factor. I'll open two parentheses, not equal 0. Let's not do equation. Immediately I open two parentheses. The square root of x squared is x, and the square root of 36 I know is 6. One of the parentheses positive, one of them negative. Another one, x squared plus 25. Can I factor? Be careful. We call this one the difference of the squares, not the sum of the squares. You cannot factor this. Oh, we may factor, but we end up with the imaginary numbers or complex numbers, which we don't want to do that here, correct? We cannot factor it. The third type is x squared plus bx plus c. For example, x squared plus 7x plus 10. This is the most common one that we use a lot when we are dealing with quadratic equations. What to do here, how to factor uh, these types of polynomials when you have three terms. Choose two numbers. Later I will use R1 and R2. Anyway, I'll explain those, what is R1 and R2. For time being, just remember, choose two numbers, R1 and R2, or you can name it anything, but I used R1 and R2. How to choose these? If you add these two numbers, it should gives you always B, this number, the coefficient of X. And at the same time, when you multiply these two numbers, it should gives you C. If you can find those two numbers, easily you can factor. But how to choose? I'll give you 4 cases. You have 4 cases. Case number 1. When B and C are positive. If B and C are positive, always choose R1 and R2, both positive. I'll explain in a numeric example now for you. X squared plus 7x, let's say plus 12. How to factor this? How to choose those numbers, R1 and R2? This is a question that, I'm sorry, some of the students are asking me, how do you know these numbers? That's easy. It has a trick. You are not thinking which numbers, right? Look at your C. Try to find all possible factors of 12. Possible factors of 12 means which two numbers you can multiply to gives you 12. Write down all of them, make a list. 12 times 1 gives me 12. And you see, I choose both of them positive. Even let me put here the sign. Usually we don't write the sign. What other two numbers? 2 times 6 gives me also 12. 3 times 4 also gives me 12. There is no any other number to multiply and gives you 12. Now, when you list all these factors, look which pair, if you add them, gives you 7. It means one of them is your R1, one of them is R2, correct? R1, you see here, R1 times R2 immediately gives you 12. All of them gives you 12, 12, 12. But find R1 plus R2 should gives you 7, which is B, right? Which pair? 4 and 3. And you know both of them is positive. Now factoring is easy. Immediately open two parentheses here. Put X here and X here. Both numbers are positive, both parentheses are positive. What are the numbers? 3 and 4. Here you go. You factor out. It's not that difficult. If you know the trick, this is the trick. I know in school they explain to you to use this cross or this method. I don't know. There are different ways that people are like explaining. I like it this way. Correct? Case number 2. When B is positive, B is, let's say, uh, let's put it in nice order. B is negative, C is positive. For example, x squared minus 9x plus 20. You see, your B is negative, your C is positive. Now, how to choose R1 and R2? Look for the product of 20, all of them, correct? Sorry, not product, the factors of 20, which is 20 times 1, 2 times 10, 4 times what? 5. How to choose the sign? If your B is negative and your C is positive, choose R1 and R2 both negative numbers, like this. Because we know negative times negative gives you positive and negative plus negative gives you a negative number. That's the reason behind. Now, which pair gives you 20 when you multiply? All of them. But which pair gives you negative 9 when you add? This pair. Then open two parentheses like this. X and X, negative 5, negative 4. You are done. Correct? Case number 3. When B is positive, C is negative. Correct? For example, x squared, let's say plus 8x minus 20. Correct? How to deal? Again, look for R1 and R2. All possible factors of 20. It's 20 and 1, 2 and 10, 4 and 5. How to choose the sign? That's important. Remember, if B is positive, C is negative, your greater number, choose your greater number positive, your smaller number negative, like this. Correct? Which pair now? This pair, you see? Positive 10 times negative 2 gives you negative 20. Positive 10 minus 2 gives you positive 8. Then I found the factors easily. X and X plus 10 minus 2. Last case, case number 4. When B is negative and C is negative. For example, x squared. Let's do the same example. Minus 8x minus 20. Again, R1, R2. Factors of 20. 20 times 1, 2 times 10, 4 times 5. If B is negative and C is negative, which case we are dealing with? C is negative. In this case, choose your greater number negative, your smaller number what? Positive. X and X, of course, negative 10 and positive 2. These are the most important factoring. One more that I want to share, discuss it with you. It's when you have x squared plus 2ax plus, let's say, let me write down in a way that you saw it before. The other factoring, we call it the perfect square trinomials. For example, if I have x squared plus 4x plus 4. Why we call these trinomials a perfect square trinomial, this type? Remember this product when you have a plus b squared and it gives you a squared plus 2ax, 2ab, sorry I used b, 2ab plus b squared, or the negative one, only this sign changed just to negative. The right side, we call it a perfect square trinomial. Why perfect? If you take the square root of the first term, if you take the square root of the last term and multiply them and multiply by a 2, by number 2, it gives you always the middle term. Look, the square root of the first term, x, the square root of the last term, 2, and times another 2, it gives me 4x. How to factor these? Come this way. The factor is always, if it's plus, put x plus 2 and in the top square. It means both factors are the same. Even if you do this problem the way that I explained 4 cases for you, you will end up with 2 parentheses the same, and we write usually this way. Correct? Why I'm explaining this? Because later I will explain the completing a square method for you. And you have to know how to do completing a square. And what does it mean, completing a square? We do completing a square on some trinomials to change their form to a perfect square trinomial. They are not a perfect square trinomial, but you can make them a perfect square trinomial. Correct? This part of the lecture was extras for you. Now I'm going back to your book, and again I'll talk about quadratic equations. The first method that I discussed with you was factoring, correct? Let's do some examples and solve some problems. Example number 1, solve x squared plus 12x plus 35 equals 0. How to solve? Can I factor? Let's see. Open two parentheses. What are the possible factors of 35? 35 times 1. Of course, you cannot use 3. You cannot use 4. 2, 4. But I can use 5. 5 times what? 7. Which pair to add gives me 12? Of course, this one. 7 and 5. After few practice, after you did a little bit practice, even you don't need to write. By looking to the problem, you know what are the numbers, correct? Both of them is positive. I'll put both positive. One of them is 5, one of them is 7, equals 0. Now I'll use the 0 property of the equations. It means set each parenthesis equal to 0, x plus 5 equal to 0, x plus 7 equal to 0, and solve both of these equations. Here, subtract 5 from both sides, then x is equal negative 5. Here, subtract 7 from both sides. It means you end up with x equal negative 7. We call these two the solutions for the given quadratic equations, or you can call it the zeros of the given quadratic equations. Usually we use the word zeros when we are dealing with functions, or you can call it the roots of the quadratic equations. Correct? Let's do another example. Example number 2. X squared minus 64 equals 0. Both of them has a perfect square root. Then I'll open two parentheses, x and x, one of them positive, one of them negative. What is the square root of 64? 8. Now set each parenthesis equal to 0, x plus 8 equals 0, and x minus 8 equals 0. From here, subtract 8 from both sides. It means x is equal negative 8. Here, add 8 to both sides. It means x equal positive 8 roots of the given equation. Correct? Example number 3 or 4, I'm not counting. I'll just put example. 3x squared plus 12x equals 0. You see, it's a GCF factoring. Factor out between 3 and 12, the GCF is 3. Between x squared and x, x. Open a parenthesis. 3x squared divided by 3x gives you x. Plus 12 divided by 3 gives you 4, and x cancels out with x equals 0. Now set each one of them equal to 0. I see this one as a term, right? 3x equals 0 and x plus 4 equals 0. From here, divide both sides by 3, x equals 0, right? 0 divided by 3 gives you 0. Here, subtract 4 from both sides. It means x is equal negative 4. Correct? This is the first method that you use factoring to solve a quadratic equations. I'll divide my lecture in 3 parts. Correct? In part 2 of this video, I'll explain to you how to use completing the square to solve a quadratic equation. And in part 3 of this video, you will see I'll use the quadratic formula to solve a quadratic equation. And also in part 3 of the video, I'll explain to you how to find a quadratic equation if the roots are given. It's also another very interesting topic. If someone gives you the two roots of the quadratic equation, even you can write the quadratic equation. And also in part 3 of the video, I'll explain to you what is discriminant. Correct? I'll stop the lecture here, the part 1 of this video, and see you all in part 2 of your lecture.